to them, which is kind of an interesting thing. It allows certainly a bit of power in what your application can do. Now, activity is meant to, because it's user-facing, it's going to be given a lot of priority by the Android OS whenever it's actually being run. So this will get a fair amount of CPU time. As you know, Android OS has allowed background applications and background tasks to be run for quite a while now, and one of their solutions was to prioritize what the user is actually interfacing with. Services, they also tend to be prioritized relatively compared to some other things, but not quite as much as the user-facing activity. If they're running out of RAM, for example, perhaps it will free up some services that were running stale or running that the user wasn't actually using. Content providers and broadcast receivers, these are smaller things, but they're meant to be very lightweight. They're meant to be, this is something that's happening as a result of this system call, so let's get it done quickly and be done with it. Now, are there any questions on this so far? I realize this is a little abstract, mostly in an attempt to point out some of the differences between the way that iOS would work compared to how Android actually functions. Oops. So how then do we actually create one of these applications? Well, the short answer is that you go to developer.android.com. And this actually, for you as an Android developer, is your home base. There's an enormous amount of information here. The API documentation, there's a lot of updates. Whenever new versions come out, there's a lot. I mean, there's just a wealth of information that's fantastic. You can also download the SDK from this website. You'll notice if you go to the website, though, that there's two versions of the SDK. There's the Software Development Kit, the SDK, and the Native Development Kit, the NDK. The Native Development Kit is a bit lower level. It allows you to write high-performance applications in C or C++ and basically embed them within an Android application. We're going to essentially ignore the NDK, but if you are interested in high-performance native applications because you need to create a game, for example, a very graphics-intensive game, then you might pay more attention to the NDK. But for the vast majority of us, we don't really care about that. It's nice that it's there, but we're not going to quite use it. The Software Development Kit is the way to go. So there's a couple of things to note about the SDK. First, when we create an Android application, we're actually writing code in Java. The end result isn't a Java program, and I'll explain more about that in just a moment, but the code that we write is actually in Java. We can use, if we want, again, as part of this openness, slightly more open idea, we could use a variety of different development environments. The one that's recommended and that's actually included with the SDK if you download it is Eclipse. You could just use plain text files if you wanted. You can kind of do it however you want. But you'll notice that using Eclipse tends to be the fastest and the best option for us. So what then, what is the process for us to build an Android application? Well, I mentioned that we have to write the code in Java. And there's a few important things that distinguish this from Java, and I'll point those out when we actually look at a Hello World example. Then we have to compile this into some Java bytecode, just as we would a regular Java program. But Android itself doesn't actually run Java code. In fact, the Android platform is a modified version of Linux that runs something called a Dalvik virtual machine. So whereas in Java, it actually runs a Java virtual machine to run and execute the Java bytecode that has been compiled by the Java compiler, Google has created a slightly different version of this virtual machine that is a little bit more, well, it pays more attention to things like memory usage and CPU time, and is a little bit more fair with regard to all of those things, because in this mobile environment, we have to be very careful about battery usage and the amount of time that we spend in each of these applications. So this bytecode is converted to a Dalvik-compatible executable, which is basically just the modified version, again, of this bytecode. It is running in essence, Java bytecode, but it has been converted. Some things have actually been changed to be compatible with this Dalvik VM. So it's derived from Java, but it's not exactly the same. But this process allows us to write the code in Java and then create and compile it into an application that is actually run and understood by this Dalvik VM within the Android platform. Now, after that, we have to package it up in a special way using zip and a tool called AAPT, which actually includes some of it will actually precompile some of the information that we have, including the Android manifest file and a variety of other things, and actually create an Android package. So you might remember that I said before that this has gotten a bit easier. Well, it's always been a little bit easier than this. If you are kind of the hardcore hacker person that loves to do everything manually, you can certainly do this. But for the rest of us, you can just download the SDK, which includes Eclipse, the IDE, and also the Android Tools plugin, the ADT plugin, and allows you basically just to go straight from the code directly to the end result, the Android package. You can find all of this on developer.android.com. And one of the ways that it is much easier now is that they actually package all of this up into one download. That makes it much easier. Before, it was really a pain. You had to download Eclipse, and then you had to download the SDK, and then you had to download the Eclipse plugin, and you had to get it all to work together. But luckily, we don't have to do that anymore. It comes in just one nice package. Makes it very easy for us to do development. So again, if you're actually interested in this, go to the website, developer.android.com/SDK/index. Download the SDK, and that's it. You pretty much can get started with it right away. So from here, how do we actually create an application? Well, of course, the Hello World app is the simplest thing that we can do to actually create an application. And there's a couple of things that I want to point out about the code in this Hello World app. And I'm going to switch here to this other screen because it has better text color and it makes it a little bit easier to take a look at what's going on. So at the very top of this Java file, we basically have a couple of things. One is package information. How many of you have developed for Java in the past or at all? Pretty much everybody. Okay, so for those of you that haven't, it's very similar in syntax to C or C++. Of course, there's a variety of differences. It's meant to be very heavily object-oriented. And I'll try to point out as many differences as I can, but I don't really want to do a Java primer right now. If you do a search for Java tutorials, you will find some very excellent tutorials by Oracle that talk a little bit more about this. But we have to put all of this code into the scope of a package, into a particular namespace, and so that's what we're doing in this first line. Then we're going to import a variety of libraries that actually make it possible for us to run this code. The activity library, which we just talked about, a couple of other things which are actually required for us to run this. The bundle is required by the OS. This log one isn't really required unless we're doing some logging, which there's some very basic logging at the very bottom of this code, which we'll look at in just a second. And also a widget. You can maybe guess by the name what this actually does, but it's essentially this. It allows you to place a text object on the activity and allow you to view some text on that on the screen. So that's just all sort of some initial setup that we have to do. And this is the contents of the code. Now, one thing that you'll notice, for those of you that are Java developers, that's very different from other things, is that there's no main method. There is no method that makes it very obvious where we're actually starting the application. And the reason for that is that the main method is done by the operating system itself. What the OS does is it looks at the manifest file that we've actually created. And so this is a full-fledged Android manifest file that has been not redacted for simplicity, so that we can actually see how some of these things work. Again, notice that this is the manifest XML element. uses a minimum SDK version of 3, which is now ancient. There's no need for you to use version 3. That's like Android 1.5 or something. So only if you want maximum compatibility do you really need to do that. But even then, there's problems using minimum SDK version of 3. It implies certain permissions that are not necessarily what you would want. I think it wants full access to contacts and some other stuff that if you just upgrade the minimum SDK version to 4 or 5, then you lose a lot of these problems that actually existed. But this is meant for maximum compatibility here. Now the application, within it we actually define where the icon is for that app on the home screen of the device. It's within, you'll notice, @drawable. Remember I mentioned that drawable directory within our resources. We can have various resolutions of our icons to support the different density and different sized screens that might exist. Similarly, can we actually apply a label to the name of that application within the string resource? And provide, you'll notice that here we're looking for a specific resource within the string directory called an app name, which you'll just have to trust me for now that it says something in English. Now, if we skip this and go down to activity, notice that we have defined one activity here. And within it, we have this idea of an intent filter. And what this intent filter actually does is it notifies the OS what this activity should actually do. And there's a variety of filters that we can apply to it. Perhaps we want to restrict this activity from being open in other applications. Remember that I mentioned that within tasks, we can have other applications request an activity. We can explicitly disallow or allow that with these intent filters. But also, we apply these two elements to this intent filter, telling the OS that this is the main activity, and this is the one that I want launched on boot. Or on boot is opening the application itself. And so really, there's no main method, but that's because we've told the Android OS that we have this activity, and this is the one that we want to run. Now, the activity itself, excuse me, the activity itself goes through a life cycle of sorts. There's a variety of methods that allow you to run some code when the activity has first been called upon to actually open, and then things have been rendered on the screen, and then it's finally ready for use by the user. We're going to ignore a lot of those for now, and I'll defer to the Android documentation for you to get more information on that. But now we can take a look again at our Hello World code and realize how this is actually working. We have a public class, code1. This is just the class for this one activity. Extends activity because this is, in fact, an object of type activity. I actually want to create some code that launches an activity and displays something to the user. And within that, we have this one method, onCreate. This method is invoked by the OS within this activity object whenever this activity is about to be started. It's saying, OK, I am about to display this activity, so I'm going to create it and display it on the screen. What do you want me to do? It's asking this code, and by asking, I mean it's invoking this method, which allows our code to actually create the layout and apply a layout onto this activity and then display it to the user. So the next few lines, this super.onCreate, we just have to make sure that we actually invoke the main activity class's onCreate method just to do any house cleaning. Otherwise, you will get a very nasty error from the Android plugin or from the SDK when you do this. And then programmatically, are we actually going to create a text view that says some text? We're going to create a text view object, just basically instantiate it in this first highlighted line. Next, we're going to set the text to be displayed by this text view. And then we are going to set the content view, which is the content displayed within this activity. So this is not necessarily a mysterious function call. This is actually a function call that's implemented by the Android activity class that allows us to set the layout for this activity. So basically, the layout for this activity will be what? Any guesses based on this code? Yeah. That's right. So the only thing that will be on screen, when we actually run this activity, will just be a text view. But that text view itself is invisible. We don't actually see its bounds. We just see the text that's contained within it. So we should expect to see the text, oh, hi. Now there's some logging capability stuff down here, which if we had a little bit more time, I would